Okay, so here we'll be introducing the topic of weighted averages and how do we use them in mixtures. So we'll do this using an example. So suppose we have three subjects A, B and C, and the total marks of these three subjects are 100, 150 and 50. So the total marks is actually 300 for all the three subjects. Now the percentage marks obtained in subject A is 40, in subject B is 60 and in subject C is 80. Now we have to find the aggregate percentage of this particular student. So how do we do that? We cannot really average these three percentages because the total marks of all the three subjects is different here. So what we do is, instead of averaging these percentages, we take a weighted average. So these will act as weights here because weight of A is 100, weight of C is 50. Basically this means that A is more important than subject C and A will have more weightage in the aggregate percentage than subject C. Similarly, subject B will have the highest weightage in the aggregate percentage more than subject A and subject C. So now how is aggregate percentage computed? We simply multiply the weights with the corresponding scores and then divided by the total sum of all the weights. So the aggregate percentage in this would be computed as 100, this 100 into 40, which is the corresponding score, plus 150 into 60. We simply multiplied these two, and then plus 50 into 80 whole divided by the total sum of all the weights, which is 300. So this comes out to be 100 into 40 is 4000 plus 150 into 60 is 9000 plus 50 into 80 is 4000, and we divide this whole thing by 300. We will get, so 9000 plus 4000 13,000 plus 4000 17,000 divided by 300, that would be 170 upon 3. So this is the aggregate percentage for this particular student. Now we'll be looking at another simple problem from the mixtures topic. So we'll be again using the concept of weighted average here to solve this. So here we have been given a 15 liters of 20% alcohol. So 15 liters and 20% alcohol is mixed with 12 liters and 24% alcohol. Find the concentration of the resulting solution. So resultant percentage concentration would be once again in this case this column will be the weights, because more the amount of particular liquid, more will it contribute to the resultant percentage concentration, and these are actually the scores here. So once again, if we apply the formula 15 into 20 corresponding score with the weight plus 12 into 24 divided by the total sum of weights, which is 15 plus 12. So this will come out to be 300 plus 12 into 24 is 288 divided by 27, which is 588 divided by 27. So we can further simplify this. So this will be 221 point so this is left 980 16, so 70, we are left with 70, and 9 goes by 7, so 763, so 21.78%. This is the required resultant concentration of the mixture. Now note that whenever we are talking about mixtures, the concentration would always lie in between the least and the highest concentration of the components. So clearly the answer here was 21.78, which lies between 20 and 24. So this is the way how we handle the mixtures and how we find out the resultant concentration of the mixtures.